Okay, so every single thing, listen up, every single thing we've done so far had to do with what kind of triangles? Right angle triangles, okay? So the question is always, what if my triangle, or what if the triangle does not have a 90-degree? Does that mean that all of math fails and we have no idea how to find sides and angles in a non-right angle triangle? Absolutely not. We actually have what? We actually have two ways. So today and tomorrow we learn one way, and Thursday and Friday we learn the other way. So today we start with the new method to find what? To find every single thing about a triangle that is not what? That's not a right angle triangle. So what if the triangle is not a right triangle? How can we find unknown angles? Again, without using what? Without using rulers or protractors. So how can you find unknown angles without using protractors, or unknown sides without using rulers? Okay, we know that SOHCAHTOA is completely useless. We know that SOHCAHTOA, you just cannot use it. Okay, and by the way, it's going to be a very common mistake, even when you have, because it's for your first time knowing this, even when you don't have a what? A right angle triangle, to still try to use what? To still try to use what? SOHCAHTOA. And sometimes the triangle looks so much closer to a right triangle that you think that your answer does make sense, but it actually doesn't. Okay, but it's a force of habit because we've been using SOHCAHTOA for so long. You're gonna think, oh, I can just keep using that. No, you can't. If it's not right, you cannot use SOHCAHTOA because it's useless. Why? Because of one reason. Because SOHCAHTOA needs what kind of an angle to be present? 90-degree. If there is no 90-degree, there is no hypotenuse, which means SOHCAHTOA does not work. Okay, so it needs a 90-degree angle to work. Okay, well, there must be something else we can do. There is. So today we learned the what? What is it called? Again, the sine law has nothing to do with SOHCAHTOA. It's a whole new beast. It's a whole new thing. Sine law is something different. Okay. Um, the way we're gonna learn the sine law today, before telling you what the sine law is, we're gonna discover it together. Okay? So I'm gonna have what? I'm gonna have two triangles here. I'm gonna run through this one with all of you, and this will be what your homework to discover it on your own. But I'll actually give you all the values that you need to what? To discover it. Okay? So number one. So let's look at a couple of non-right triangles. By the way, what makes this one? What makes this one non-right? Do you see any right angle triangle? Sorry, do you see any right angle here? No way. This is definitely less than 90. This is definitely less than 90. And this is what? Slightly what? Slightly bigger than 90. By the way, what do you call a triangle that has one angle, only one angle, bigger than 90? Obtuse. See, if there's one obtuse angle in the triangle, you call this what? An obtuse triangle. So go ahead and just write obtuse, ABTUSE, obtuse triangle, because there is an obtuse angle in it. Triangle. Okay, what do you call a triangle that doesn't have any obtuse angles? All the angles are acute. This is less than 90. This is less than 90. This is less than 90. Then that means what? This is an acute triangle. So your homework is gonna be what? To do the exact same amount of work. I'm gonna be the obtuse, but for the what? But for the acute triangle. Okay. All right. So what do we need to do here? Well, let's look at the steps. The steps say label the vertices. All right. We always have to do that. So I guess I'm gonna go with the ABC. So go ahead, and I'm gonna go with A here. I'm gonna go with B here. I'm gonna go with C here. By the way, my solutions, my field notes might slightly look different. Maybe the A is here, maybe the B is here, but it's gonna be the exact same message. Okay. So step one is label the what? The vertices or the corners. Then you label this what? The what? The sides. How did we label the sides in trigonometry? Using what three words? In trig, in SOHCAHTOA. What words did we use? Hypotenuse, opposite, and adjacent. Can I use these words here? No, I can't. There is no hypotenuse. By the way, a common mistake is people saying, well, this is the longest one, so it has to be the what? Hypotenuse. That's not correct. Why? The hypotenuse is not just the longest one. It's also the what? The, say again? It's the one that across from what angle? 90. Is this 90? Because this is not 90, this is not hypotenuse. So you cannot use opposite, adjacent, or hypotenuse. So what do we use? We use small letters. What angle do we have here? Small a or capital A? Perfect. So the one opposite to it gets named what? Small a. This one is what? Capital B. So where is small b? Right here. And this is capital what? And this has to be what? Make sure that when you write by hand, you make, because the C capital and small could look the same, make sure that one of them is bigger than the other. Okay, so we're gonna say this is B, so this has to be what? Small b. Go ahead. This is capital C, so I'm gonna make this one a smaller c. And this one is small capital A, so I'm gonna make this one a small a. From now on, whenever you have a non-right triangle, you have got to label this way. Capital on the corners, small on the sides. Perfect. Okay, what else is there? Okay, using a protractor, measure the what? Each angle. Using a ruler, measure what? Each side. I'm going to do both for you because I already have the website from which I got these two triangles. All right? So all I have to do is somehow create this triangle all over again. All right? Check this out, everyone. Okay, here is my, I don't need this or this. Here it is. Okay? Okay, I need to create my triangle. So let's see. Now I'm going to keep playing with it until it kind of looks as much as I can to this one. Let's see. Oh, sorry. All right. Do I still need to change it? Yeah. I guess I need to tilt this one to the right a little bit. So let's do this. What do you think? Close enough? Again, it doesn't have to be exact. Just the message has to be there. Let's see. Those two seem to be parallel. Those two seem to be parallel, which means those two seem to be parallel. Perfect. Now I'm going to ask the website to what? To give me all the angles and all the sides. All right. So, okay. I need show A and A. All right, everyone. So we're going to say that this big angle is how much? 105 degrees. And the side across from it in whatever units the website is using is how long? 10.8 what? I don't know, maybe 10 point centimeters, inches, pixel units, whatever. So go ahead and write 105, 10.8. So 105 degrees, and this will be 10.8, whatever. Don't worry about units. Okay, let's go with the other angle. The other angle is this. Show B and B. So apparently B is what? 51 degrees. That kind of makes sense. And this one is 8.7. Okay. All right. So this one is 51 degrees. And this one is, what was it? 8.7. 8.7. Okay. Technically, do I need the website to figure out the third angle? No, I don't, because I can just what? Subtract those two from what full angles in a triangle, any triangle? 180. So let's just do it by in our heads. What's 105 plus 51? 105 plus 51. 156. How much remains to make it up to 180? 24. Well, let's see if that is actually correct according to this. 3, 2, 1. It's got to be 24. And this one was measured to be 4.5. All right. So this one is 24 degrees. And what was it? 4.5. Okay. We have not done any math work yet. All we did was repeat a triangle on the website, and that website measured all the angles and all the sides. Okay. Now we actually what? Discover the sine law. Discover the sine law. So the first thing we're going to do is this. Everyone, let's go down. Let me just zoom out so you can see both. Okay. What I want you to do now with me is let's get the sine of angle what? Sine of angle. A, sine of angle, sine of angle. Okay. How can we do that? We have to use what? Cell phones or we have to use a machine basically. All right. So I'm going to bring up my machine. There we go. Do I put sine first or the number? Mine gets the number first. So I'm going to go with A. A is the biggest angle, which is the obtuse 105. 105. Do I use second? No, I already have the angle, so I just need the sine. Okay. How many digits do we always take? 4. With trigonometry, you always take 4. So we start here, and we end here. So 9659 or 9660? Like, does it stay or does it bump up? It's 2. So the 9 is what? What if it was not a 2? What if, sorry, what? Hello?
Mr. Ramadan?
Yes, hello? Yes, hello.
Yes, hello. I'm looking for attendance,
Oh,
please.
okay. Um, what if this was a 7? By the can you just change a 9 by itself? 9 is always the troublemaker. When you have a 9, you always look at the number what? Behind it, which is what now? 5. So what's after 59? 60. That's you really changed 2 numbers then. That's only when you have a what? When you have a 9. If you have any other number, no problem, because the next number is there. Like 8 becomes a 9, 7 becomes an 8. 9 cannot become a 10. It's the 59 that becomes a 60. So 9659. All right. So go ahead. Point 9659. All right. Next, sine of B. Sine of B. So clear. What's B? 51 degrees. Trig, only do the sine. What do we have here? 7, 7, 7, 1, 4. So what happens to the 1? Stays. Nothing. Thank you. So 0.771. 0.7771. Okay, last one. Sine of C. What is C? Angle C. Yes, 24. Thank you. Trig, sine. 40673. So what happens to the 7? Nothing stays the same. So 4067. Point 4067. Okay. So far, we barely used what? Used any trig ideas. All we did was just punch in some numbers on a machine. Okay. Now we're going to see something interesting. What we're going to do is do this. We are going to divide each one of those what? Of those 4-digit decimals, sine, 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 by the what? By the side length. Okay, let's actually write the side length. What was the length of A? Can someone remind me? What was the length of A? Okay, so I'm just going to write 10.8 here. Okay, what was the, so this one is here, and that's here. What was the length of B? Was it 8.7? 8.7, and this guy is here. And C was 4.5, 4.5, and this was this number. Okay, so now all I'm going to do is divide this number, which is this guy right here, by the corresponding A, which is 10.8. All right, let's see what we get. So let's do the first one clear. 0.9659 divided by 10.8. Okay, what do I have here? Sorry, say again? That is my final answer for the first one. So 894, sorry, 0894, does the 4 change or stay the same? Okay, so go ahead and write 0.0894. 0.0894. All right, let's do this one. 0.7771 divided by what? 8.7. 8 what? 93, because the 2 doesn't do anything. So point. What do you notice about those 2 values? Are they almost the same? All right, let's see what the third one says. Point what? 40. Point, sorry. Point 4067 divided by what? Point what? 904. What do you conclude? Are they close enough? Should they have been perfectly the same? Okay, why do you think they're very close enough, but not exactly the same? What prevents them from being exactly the same? It's the same thing that always prevents what? Measurement from being exactly what we expect them when we do calculations. Manel? Because when you measure, is everything, like for example, is this angle really perfectly 51 degrees exactly? Nope. But the website what? Approximates to a whole degree. Maybe this degree is actually what? 51.3? Maybe this one is what? 104.7? Maybe this one is then 24.6? Do you see what I mean? Then would the numbers be closer to being exactly the same? What do you think? If my measurements were more accurate, what do you think? Would then those decimals, would those decimals then, sorry, would those decimals then be almost the exact same thing? Yes. Again, that's why we what? We learn trigonometry because then we actually what? Know that they are the same if I could perfectly measure angles and lengths, angles and lengths, angles and lengths. That's it. So what do we conclude? Is that in any triangle, sorry, non-right triangle, sine A over A must be the same as what? Sine B over B must be the same as what? Sine C over C. Did we do something like that before? Did we go through something where three fractions were equal to each other? Yeah, which one? Similar triangles. So now we go back to what? Something of a same idea. You have to make three things equal to each other. And how do you think you're going to solve always using what? Cross multiplication. You see, cross multiplication is a skill that never leaves you. Grade 10, grade 11, grade 12, you go to college or university, you always will do cross multiplication. Always because you're solving fractions. Okay? So everyone, I'm gonna actually what? Do this one for you, but I'm only gonna figure out what? I'm gonna figure out the angles and the lengths. You will do this, and you will, by the way, are you gonna get the exact same answers? No, but should you get three answers very close to each other? All right, so let's figure this one out. Okay. So I need to create this triangle. All right. So, oops, I got. Okay. Here's the website. Okay. Clear, clear. Okay, clear. Okay. What do we? Yes. No, no. You not okay. Can you measure it? Of course you can. Do you really need to? That's why these laws were invented. Because then someone tells you what the numbers are, and then you just find what the rest of the numbers purely without what any measurements by protractors or rulers, just by doing what cross multiplication. Do you see what I mean? Which is much easier than actually what? Having to have a kit on you the whole time and actually using it. Okay? All right, let's try to build this triangle. Okay, I need a lot of changes here. Okay, so we're going to make this one here, this one here. What do you think? Yeah, this needs to be closer, right? Okay, closer to the right, yes. You know what? I need to see it from here. Okay. Okay, what do people think? Raise your hand if you think this is good enough. Think so. I'm trying to see, is the blue parallel to the blue and the green parallel to the green and the red parallel to the red? Yeah, I believe so. Maybe the red needs to be slightly lower. No, that's the thing. You can't, because if you copy paste it this way, you can actually copy paste into this editor. Do you see what I mean? You actually have to manipulate it this way. But I think this is close enough, right? All right. So I'm actually just yeah. Okay. Now I need to do what? The angles. Okay, let's figure all of them at once. Go away. All right. So show A and A. Oh, let's call it something different. I don't want you to always call it ABC. Yep. So everyone go ahead. X, Y, capital. Make sure you write your capital Y like that. And capital Z, I don't care if you put the line in the middle, but it has to look like a capital Z. All right. So I need, let's do the top one. Top one is, mhm, all right, show A and A. Okay. 66, everyone. 66 degrees. Opposite to 6.2. All right. Whatever numbers. I mean, we did not control this. 66 degrees. Oh, sorry. Sides. If this is capital X, what is this one? Small x. Go ahead. And small x has to look different than capital X. Try to, curve it a little bit like this. Capital Y, small y. My small y looks like this. Small z kind of looks like capital Z, but curved and also smaller. Okay. All right. So 6.2. 6.2. Okay, let's do the next one. Let's do B, which is the left corner. I have 69 and 6.4. 6.4. Again, no need for units. No need for units. Okay, what should this one be? 60 plus 60 is 120. 6 plus 9 is 15. So that's 135. How much remains? You're at 135. What remains to get you all the way to 180? 45 degrees. That should be 45 degrees. Well, let's check. 45. 45 with an 4.8. All right. 45 with a 4.8. And that's all I'm going to do for you regarding this triangle. All you have to do at home is basically what? Find out sine of x, sine of y, sine of z, which has got to be three different numbers. Everyone, those three are different. But when you divide them by small x, small y, small z, they should come out to be almost the what? When you divide them, these are different. But when you divide them, they should come out to be the what? Come on. Oh, exactly. Let's always keep saying almost. Why? Because we did not base it on what? We only based it on the measurements, but it actually should be 100% correct if your measurements were 100% correct. Okay. Um, so what's the observation here? The observation here is sine A over A is equal to what? No. Sine B over B over equals what? Sine C over C. So let's write this down. Go ahead. The observation here is, I'm going to write a different color. I'm going to go with red. One fraction equal to another fraction equal to another fraction. Sine of A over A must be sine, sorry, equal to, I mean, sine of B over B must be equal sine capital C over small c. What do you think the observation is going to be in the second one without even doing the checking work? Like, how would you fill this one now? Right here. Without even doing the checking work that you still have to do here and here. What do you know is going to happen at the end no matter what? Exactly. So sine x over x. So you know you're going to get sine x over. By the way, you can notice that sometimes I put it in a what? And sometimes I don't. It's completely up to you. Okay? Sine x over x must equal what? Sine y over y equals sine z over z. And this is the sine law. This is the sine law. So we can conclude here by saying what? All three ratios are what? Thank you. Equal, identical, whatever you want to say. I'm going to say equal. Now, everyone, I'm going to show you two ways to write this law. Most of the teachers you will see will write it this way. capital A, capital B, capital C, faces small a, small b, small c. So most teachers, everyone, will write this. Sine A over A equals what? Sine B over B equals what? Sine capital C over small c. There's another way to write this. It's not as common, but it's exactly the same idea. Flip all of them. Flip, flip all of them. So instead of saying sines on top, what do you say on top? The ABC, exactly. But the biggest mistake that some people make is this. They write this, look. They write sine A, look, over A equal, sorry, my bad. I should have flipped, right? I forgot. So they say A over what? Sine of A equals what? B over what? Come on. Sine B. And then they make this mistake. They say what? Equal, bless you, sine C over C. What's the mistake here? What's the mistake right there? Yes, you cannot mix the levels. Either all the signs are at the bottom or all of them at the top. You cannot have two of them like this and one. Either all three are the same or not. So, yes. Oh, sure. Yeah. So I'm going to clear and clear. C over sine C. Which one do I almost choose every time? I don't know. For ever since I learned this 25, 26 years ago, maybe my teacher never used this. I guess my teacher always used this one. So force of habit for me, once I start applying the sine law, I always write it this way. You will get the exact same answer if you write it this way, because at the end of the day, what are you going to do? When you cross multiply, it doesn't matter what goes on top and what goes at the bottom. Okay? Oh, one other thing that people make as a mistake. People write it this way. Is this correct, everyone? Is this correct? What is wrong here? What is very wrong here? Yeah, Hamza. Yes. Capitals are not the lengths. Capitals are the what? Angles. Can you ever get a sine of a length? No, you get a sine of a what? Of an angle. So that means never do it this way. Capital always goes with the sign. Small goes below the sign every single time. So this is incorrect. I want you to actually write it down and say incorrect. I want, because again, when you type up your answers or actually write them by hand, I know some of you will still write it this way, even after I warned you against it. Force of habit. Your first time ever seeing it, no problem. Make as many mistakes as you can now. Okay, test or quiz, because people are still calling them sometimes the same thing. What do you mean? Yes. No, the test is next week, next Thursday and Friday. Yes, it will be. Yep. So again, everyone, the test will have 5 topics in it: Pythagorean theorem, similar triangles, um, trigonometry, sine law, and the 1 and 2 days cosine law. 5 topics. Again, that doesn't mean, everyone, that doesn't mean that you're going to have 5 pages of questions and a lot. No, no, no. Some of the questions are going to be quick, and some of them are the questions are going to be a bit longer, because again, I'm going to test you the day before with a what? With a Google form. So whatever questions make it to the Google form are not going to make it to the written test. What's the point of giving you the same question 2 days in a row? I don't do that. Okay. Plus, it increases my marking, and you just write twice for no reason. Okay. So everything, Pythagorean, similar triangles, trig, so SOHCAHTOA, sine law, cosine law. So basically the 5 things that appear on the timetable. Okay. All right, everyone, let's flip the page and do a few examples. Okay. Everyone, example 1. How to find what? Come on. How to find what? Lengths without, sorry, using the what? The sine. By the way, why cannot you use the cosine, sorry, the SOHCAHTOA in here? Look at this triangle. Why would you get wrong answers if you try to use the SOHCAHTOA? Okay, how can you prove there is no hypotenuse? One angle is how much? 70. One angle is how much? What's 70 plus 35? can the top one ever be 90? No way, because 105 plus 90 will exceed the what? Sorry, will exceed the what? The 180 degrees. Exactly. Thank you. So that means there is no way this is what? This is the 90-degree triangle, which means we cannot use SOHCAHTOA. We have to use what? Sine law, today's lesson. Okay. Can I find out that angle, though? Yeah, let's do that. So go ahead, everyone. Point to it. Okay, how much is that? Well, 70 plus 35, as Hamza said, is what? 105. How much remains to get you to 180? 75. Thank you, everyone. So go ahead and write 75 here. 75 degrees. Okay. Is the labeling done? All of it. What's missing as far as labeling is concerned? Exactly, the A, B, C, small. I have the capital A. I have the capital B. I have the capital C. They've already labeled what for me? Small b. So I need to label what? Small c and small a. All right, go ahead. Small a. I'll put it here. Doesn't matter inside or outside. And small c. Okay, let's use the sine law. Well, let's write the sine law. Sine, let me get some grid lines to help me write. Yes. Okay, sine a over a equals sine b over b equals sine c over c. Question for you. When you did this for the similar triangles, after you wrote AB over XY equals CB over ZY, whatever, what did you do immediately after writing that? Patrick, say again. Exactly. So plug in all the numbers you know, or at least say what do you know and what do you not know or need. Do I know angle A? Everyone, come on. Do I know angle B? Do I know angle C? If you know all the angles, can you just plug in and get all the signs? Yeah, because all you need is a what? Is a calculator right here. Perfect. So check mark, check mark, check mark. All right. So 3 green check marks. Check, check, check. Okay. Do you know length A? No, you don't. So question mark. Do you know length B? No. Question mark. Do you know length C? It's 25 centimeters. Check. Do you have a good fraction out of all of these three? Yes, you do. It's the C fraction because it's fully known. However, which one of those two are you going to use with this one? Okay, it doesn't matter, but which side apparently does the question want you to find? They want you to find just the what? They could have asked you to find what? A or both, but they just want you to find, which means which one of those two you do not need. Which one do you not need? There we go. So you hide this guy. Can you cross multiply those two? Yes, because you have how many check marks? 3. And how many question marks? You can only crisscross if you have 3 check marks, like 3 things you know, and 1 thing you don't know. So go ahead, everyone. Box this one and say what? What do we say when we don't use it? Useless. Thank you. So useless just because the question doesn't want it. Could I give you a question where I say find both A and B? Yes, but which then means what? It doesn't matter which one you find first. You could hide this one first and then cross multiply, or you could hide this one and then cross multiply these two. Perfect. All right. So let's, as Patrick said, let's put in the numbers now. So sine, okay, sine what? B, which is 70 degrees. You can put it in a bracket or not, but at least put the degrees, please. Over. Do you know the B? Do you want to know it? Do you put a question mark? Okay, you could put X. Or you can just keep calling it what? Remember, X is fine. But if it already has a symbol, just keep calling it that symbol. So equal B equals sine of C is 35 degrees over 25. All right, we're building up. Nice. Okay, fraction over a fraction. B is here, 25 is here. Okay, I need those two numbers to 4 digits. Let's find it. Clear? Clear. Okay, 70 degrees sine. How much would that be? 93969. Huh. Exactly. So again, remember, this is the 9 case. Everyone look. 93969. So this 9 will bump up 96 to what? To 97 or just 7. All right. So 9397. Okay. So point 9397. Yeah. Make mistake. We're good. All right. Again, I make mistakes all the time. So let me know. 35 degrees. How much is the sine? Pretty small. 5736. 5736. And now what do? The only step in math that's left. Cross multiply. So those two multiply and those two multiply. All right. What do we get? We get B times this guy, which is just 0.5736B equals, okay, I have no idea what this is. Well, we'll find it out right now. 25 times 0.9397. How much? By the way, keep the number. Keep the whole number. Round at the end. Round at the end. So it's got to be 234925. So 234925. How do you solve anything that looks like this? Come on. Shadi. Exactly. So you can say divide both sides by what? Which number? Exactly. By the number next to the thing you want to find. Or you can just say what? One solid step. B equals this guy divided what? This one. So you can just jump to this step. Remember, on Google Forms, you can just write it as a slash. No way you can write a fraction. So 234925 divided by 0.5736. Okay. What's the rounding situation? Let me just check. Rounding is one decimal place. Okay, that's fine. Let's see. What do we have here? Clear, clear. Okay. 23.4925 divided by 0.5736. 1, 2, 3. Go. All right. What is this to one decimal? Interesting. It is 49.9, but the 5 is going to bump up the 9. But the problem is you can't bump a 9. You have to bump the what? The one before it. What's the number right after 40? But you have to show a what? Like Shadi said, again, the question says show one decimal place. If there's nothing to show, just put a 0. So the final answer is 4. You know what? I'm actually going to write it as a two-step, just so you understand what's happening when you look at the notes. 4.95. And then I'm going to make the cut right here, which means it will be 41.0. Is there a unit in this problem? You have got to make it, otherwise you lose half a mark from the very, very, very final answer. Ladies and gentlemen, that is how we do the sine law. Okay, let's just do one, and we're done for the day. Sure, yes. Okay. Can I find the third angle in that one? Yeah, whenever you find two, if there are 3 players and all of them add up to 180 and you know 2, you are guaranteed to find the third. Let's find this one. How would you find it? You have to add 65 and 58 first. What's 65 and 58? That's 110, 123. How much do you still need to bump up to 180? 57. You're right. Yes. And again, just to check, 180, take away 65, take away again 58, 57. Perfect. 57 degrees. By the way, what do you call a triangle that has, okay, what if those two were the same? What do you call the triangle? What do you call a triangle that has 2 identical angles? Which will also mean it has 2 identical sides. What do you call a triangle that has 2 identical angles only? Not 3. 3 would be 60, 60, 60. That's only what? Equilateral. What do you call it when you only have 2 and the third one is different for sure? Isosceles. Is that exactly isosceles? Is it almost isosceles? Yeah, I mean, those two are almost the same, which is why those two lengths are almost the what? The same as well. Just saying. All right, let's label. I have D, E, F. Apparently, they've already labeled the small d for me, which means they want us to find lowercase d. So that means I need to to label small e and small f. My small f looks like this. Look, it's not so fancy, it just looks like this. Everyone, your small f could look like this. Please, don't make it, again, some people, like in physics, we use this a lot for frequency, and people call this the fancy f. I'm like, this is fancy? You have a low bar for fancy. Okay? All right. Let's do the law. Sine. Okay, sine what now? I don't have ABC. What do I have? Capital D, capital E, capital F. Thank you. So sine of capital D, sorry, not B, D, capital D over small d equals, this is D, not A. Sine of, yeah, it doesn't matter, E or F. You got, by the way, you have to write all three. So it doesn't matter in what order you do. But it looks nice when you do it just like the alphabet. Equals what? Sine F over F. All right. Like Patrick said before, let's see what we find, what we have. What do we have this time as well? Do we have all three angles? Which means we have all three top parts. So we have sine D, sine E, sine F. Now, which one of those three are we trying to find? Which one? Small d. So that means this is a question mark, which is the one we want to find. So question mark, question mark. E, do I know it? Nope. Another question mark. F, I do know it. So it's another green check mark. Okay. Which one of those am I going to hide? Come on, tell me. Which one? Yeah, you're right. This is the one we're going to hide. So that means we're going to relate this fraction to this fraction. Okay. So I'm going to square this, or sorry, box it and say useless. Again, you don't have to do that. I'm always going to just emphasize which one really we don't need now. All right, let's do this. Sine, what's capital D? 65 degrees over small d. Don't call it x. Just keep calling it small d. Sine of what the 58 over. Sorry, where am I? F 60. All right, get some numbers. Let's do this. 65 degrees. What's the sine? How much? 906. 906. 3 or 4? 3. Yep. I'm got it. 3.9063 equal 58. What's the deal here? 848, 0 or 1? 848, 0, because the 4 does not do anything. This one is not going to touch this. So 8480. Our friend cross multiplication. Press cross. So point 8480 D equals whatever that is, 60 times 0.9063. 54,378. Again, whatever number I have here, I'll just write the whole thing. 54. Yes. This is the, yes, 8480D. You do not have to show me a multiplication sign or anything. Because remember, 2x is the same as what? 2 times x. Never write what? A multiplication sign between a number and a variable. Just write the number next to the variable. All right. And our last step is that small d equals this number divided by this number. I wonder what we have. Let's see. This divided by 0.8480. Okay. How many people got this answer? All right. but we're only allowed to show how many decimals? 1. So what would that be? 64 point what? 1. Okay, 0 if it was a 0 here and nothing rounds it up. But it's already a what? It's already a 1. So you make the cut. Again, I'm going to show you the cut in the solutions. So it's 64.12, and we're going to make the cut right here, which is going to lead to what? 64.1 in what unit? Thank you. And we're done for the day. So your homework is the last one. Your homework is this one, which is exactly the same idea. You are finding length x, which means you are not using z, but you are using y. And you need to find this one. What is this one quickly? What's 55 plus 47? That's 90. No, 102, which means that is 78. Everyone, 78. And now you have everything ready.